and I think about the physics and chemistry of climate change and what's going on there. So one thing that I want to be clear about is that the driving force behind climate change really is the increase in CO2. It really is the increase in greenhouse gases, of which CO2 is the most important one. And this is a time series that goes back to 1958, showing that we've got CO2 on the rise, and it is increasing every single year. So seeing these data, I hope you'll understand why every single year you will be hearing an announcement about how we have hit a new level in terms of CO2. And fundamentally, the reason for that is that once CO2 gets up into the atmosphere, it stays there for hundreds and hundreds of years. So anytime we pump something up into the atmosphere that is as long-lived as CO2, it's not going to dissipate very quickly. But CO2 isn't the only greenhouse gas, the only gas that has the ability to warm the atmosphere. Methane, water vapor, and various chlorofluorocarbons can also do it. Methane usually kind of turns into CO2 eventually in the atmosphere, and which is part of the reason we focus so heavily on CO2. But they're not the only factors that influence climate, as I think most of us already understand intuitively, but actually become important to us in climate science so that we are really integrating all of our knowledge of about what's going on. There are an awful lot of local factors that can affect our climate. In particular, the local heat. When you're in an urban area, particularly an area like New York City or Boston or Chicago, it can be 10 degrees warmer in the city than outside of the city. So we need to be able to separate out what are the long-lasting effects and what are the local effects. There are also circulation issues and water issues that can affect the local climate. But on very long time scales, and this can sometimes get confusing for some, we've got other planetary issues that dominate. The Milankovitch cycles, if you've studied those, and people will talk about, we've had ice ages in the past, we've had warming, it's all a cycle. Well, those planetary issues really aren't what we're talking about, what's happening in this century and in the past century. The Milankovitch cycle is something much, much stronger and dominated by the Earth's orbit and the tilt of the Earth's axis. And that's not what is causing any unusual changes that we're observing now. I showed you just a moment ago the sort of time series showing CO2 increasing globally year after year after year. If we talk about how much is that increase each year after year after year, that's what we're seeing in this plot. We're seeing how not only is CO2 increasing, but how much we're adding every single year increases. So we are not exactly conquering this issue of CO2 rising in the atmosphere. Not only does it continue to rise, but how fast we're pushing CO2 into the atmosphere is also continuing to rise. As a scientist, I want to talk about what we know and what we don't know. And as a research scientist, that's exactly where I and my colleagues like Dr. Arujo and I work. We work on that interface between what is known and what is unknown. And there are at least 4 different categories for what we know and what we don't know. There's what we know, what we know we don't know, what we don't know we know. And then there are the things, the surprises, the parts that we haven't been thinking about yet, but perhaps we should have been, and give us a little more time, and then we'll think, golly, why hadn't we incorporated that into our thinking back then? So I will try to help you understand where we are as a community in terms of what we know and where we're making progress and where it's really hard to make progress. And to the extent that I can, I'll share with you why it's hard sometimes to make progress in these areas. But I want to say that climate science is always working on that interface between what is known and unknown. And we have a few ways to divide up our efforts at pushing that boundary between what is unknown and what is known. We really work on our understanding. That's fundamental to it. And we use measurements, we use models, and we look at the impacts of climate change to try to see if we can understand what's going on. But there are 2 other areas of active research that are, I think, becoming more and more important to us. And they have to do with how we as humans respond to climate change. How do we adapt and how do we mitigate? And I'll be giving you a few ideas on what's going on in those areas as well. And actually, to address those 2 areas, we have to move being more inclusive than just science and really take a look at what's going on policy-wise and what's going on engineering and what's going on with the business of responding to climate change. So I also want to be clear that I'm talking about climate science is working on the interface between what's known and unknown, but really all science works on that interface. So that is what research science is all about. So nothing special about climate change in that aspect. So I want to start with how do we know what we currently do know? And we focus on our understanding of what's going on. We focus on measurements and we focus on modeling. You know, sometimes I don't know how many of you in high school or in middle school got introduced to the scientific method and you did an experiment, maybe putting two chemicals together, maybe doing vinegar and baking soda to make your volcano explode and realize, hey, it doesn't work if you don't use vinegar, and you do controlled studies. Climate science is not actually a field that lends itself very well to that sort of approach. We have one Earth, we have one experiment going on, but that doesn't mean that we're going blindly here. There are many areas of science that don't get to have controlled experiments with and without the baking soda. We actually have a number of fields of science that have the same challenge that climate science has. In particular, astronomy doesn't get to kind of tinker with what's going on in the stars, as well as archaeology and paleontology, geology. We work with what information we have, we pull it together in whatever way we can make sense, we challenge each other, we push on it, and we try to find ways to test our understanding. So putting understanding first, measurements and modeling are our way to support that. So one of the things that I want to make really clear is that we have one atmosphere on this earth. We have one atmosphere, and what we do in any part of the world affects the rest of the world. When we have volcanic eruptions, we see the effects around the entire globe, especially if they're the type of volcanic eruption that pushes aerosols high into the atmosphere. We'll see stunning sunsets for years later. And in fact, we know that historically is true. But not only does that affect how our sunsets look, how bright orange they look, but it affects the climate around the world. We know that the volcanic eruptions can cool the planet because of the aerosols, but we also know that a strong volcanic eruption, such as what happened in 1816, turned out to be the year without a summer for Europe. It ended up cooling the planet so much that crops failed and people died. So there's nothing about our current climate that is dictated to be the same way every single year, year after year after year. And in fact, we've seen multiple natural experiments that take place that show us that the temperatures that we get, the precipitation we get, changes based on what we do to the atmosphere. We also take a look at the historical record. Now, this is a kind of odd plot if you'll take a look at it with me. The top is the change in temperature over years, and the bottom plot is the CO2 level. But what makes this plot a little bit challenging to interpret is the x-axis. If we're going back in time with 500 million years ago, very long times ago over on the left, and then the x-axis is in a logarithmic form, so we're moving closer and closer to the right. So whenever we had CO2 being high, we also had temperatures being high. And when CO2 was varying quite a bit, we had temperature varying quite a bit. So that's one of our ways of understanding that CO2 really does dominate how our planet ends up looking. And YBP, by the way, is years before present. So we're going everywhere from 500 million years before present up until the current time. And that tiny little upturn at the very right end of the plot is CO2 going up and our temperatures going up simultaneously. So yes, we have had CO2, or we have had this experiment run in the past, and we have been able to see what it did. We also have more short-term things. The El Nino and Southern Oscillation variability that takes place every single year, or not every year, but is every couple of years, shows that we can adjust the temperature, particularly in the tropics, 2 degrees higher, 2 degrees lower. We can have a lot of influence on what's going on, or we experience a lot of influence by what's going on. So again, what's happening in the oceans, what's happening over land, what's happening with volcanoes, Anytime you're affecting those factors, you're affecting our climate, and our climate does respond. So when we as human beings burn a lot more fossil fuels and put more CO2 into the atmosphere, we have to expect that it will respond. I want to talk about measurements of our Earth system. I've already shown you the CO2 plot, where we have CO2 increasing every single year. But let's talk about how the Earth is responding to that increase. So what we're seeing here is from 1910 roughly going up to 2020, and we're seeing every single continent on the Earth has been increasing. Lots of variability, absolutely. We get cold years, we get warm years, it goes on. But each of the continents around the globe, even those that are not terribly big into fossil fuel burning, is showing a pretty similar increase. Again, we have one atmosphere. And the dark blue line there is the oceans. The oceans are incredibly important for our climate, incredibly important not just for what has gone on, but what will likely go on. So we are seeing in real time the response of this Earth to CO2. Let me move on to modeling. We take everything that we can understand about the various aspects of the climate, meaning not just what the CO2 levels are, but also what's happening from our solar radiation standpoint, what the other trace gases are doing, whether they're increasing or decreasing, whether we've got local effects going on, whether we've got volcanic activity, atmosphere, biosphere interactions, and we try to incorporate them to the best of our ability into global climate models. And they have to be global, because the only way to understand this system is to really work on a global level. By the way, when it comes to high performance computing, I think my colleagues and I are the biggest single users of high performance computing around the world, possibly only second to Department of Defense in the international community. And I would love it if we beat them. I would love it if we ended up using more computing than they're using. But it does take a ton of computing to do this, just an absolute ton, which is one of the reasons why we can't always do as many controlled experiments in this computer modeling world as we would like to. So one of the biggest questions is, what will the future look like? And that is one of the biggest goals, not the only goal, but one of the biggest goals of these climate models. We develop them, we test them, we verify them, and we ask them, help us understand what the future will look like. Well, I wanna just say, first of all, that's a really hard challenge to ask of any scientist, because it's based to some extent on what's the population going to be like in 2050? How many of those people are going to be middle class and running air conditioners? What's the population going to be like in 2100? Those are really important input questions into what we're doing. Will we be using renewable energy more and more, or are we going to continue on this current path that we're going on? Those are just such difficult questions. So in general, what we do as climate scientists is we go ahead and adopt a set of assumptions, and then we adopt another set. We adopt a set of assumptions that says, hey, what if we really lean into renewable energy? What if things don't go quite as harshly as one would hope? And what we end up seeing then, if you can see this, I apologize if it's awfully small, but on the left is temperature around the globe, and on the right is precipitation. I have to say that temperature is not one of the parameters that I worry the most about, that I think the most about. Temperature is almost a sort of benchmark, or we watch what is happening. But if we have a real change in precipitation, then we have a real change in our agricultural system and our ability to feed the people on this earth. So we really have to care about precipitation. So on the left, temperature, on the right, precipitation. And what you're seeing is the redder areas are the higher temperatures, and the bluer areas are where we're getting more precipitation. On the right plot, the precipitation, we're seeing some areas getting more precipitation and some areas getting less. Now, this set of assumptions is assuming that we're going to lean really into how a lot of renewable energy, we're going to minimize our output of CO2. Perhaps we're even going to capture and store some CO2. And this is actually going out to 2100. So we're looking at, golly, some of the worst areas are looking at maybe a 4 degree change up in the northern latitudes. If we take another set of assumptions, maybe that the whole world doesn't lean terribly into it, we're looking at even more warming and even more regional changes in precipitation. Again, with some areas getting more wet and some areas getting more dry. A sort of more, people don't change their habits too much. We keep on spitting CO2 out. We're talking about a lot more warming and even more severe changes in precipitation. Some of those changes in precipitation are upwards of 30% in one direction or another. And what some people will say is the worst case scenario, it is not what I think of as the worst case scenario. We're talking about even much more warming and much more cooling. Now, we get different results from different models, and even the same model, when we run it twice or three times on the same set of assumptions, we'll get slightly different answers. But there are real common conclusions that we run to. Part of what everyone wants to know is how fast are we talking about these changes taking place? Is this something that's going to take place? You know, is life going to be different 5 years from now, 10 years from now? Can we push this down the road? Well, one reason we can't really push it down the road is that CO2 lasts in the atmosphere for hundreds and hundreds of years. So anything we do now is not just affecting us and not just affecting our kids and grandkids, but way down multiple generations. So under a lot of different scenarios, so what we're seeing here is temperature, and then on the left and precipitation on the right. Temperature kind of going up from around 1850, when we really started burning a lot of fossil fuels, the beginning of the industrial era, until around now. You can see that there's been an increase sort of in the last 20 or 30 years. And then what does it look like in the future? And based on those sort of low, medium, high, very high assumptions, we're looking at a lot of different scenarios as to how the world will unfold in the coming 80 years. So, and I'm very I want to make note that some of you will be alive in 80 years. So you will be able to see exactly which path we're going down, and you will be dealing with it. On the right, precipitation, you can see it's kind of more of a rat's nest, more of an uncertain aspect than temperature, and that's a fundamental aspect of precipitation forecasting. Precipitation is really hard. It's really hard to measure. It's really hard to predict. It's just a very difficult parameter, and yet it's so important that we in the science community keep working on it, keep trying our best for it. So we have a lot of different plots or a lot of different sets of ideas on how things might progress going into the future, ranging everywhere from 4 or 5 degrees more of warming to possibly just another degree of warming. And I say just another, and that is not a small amount in terms of what we're talking about here. Even that could have a significant change to how the world is looking. But there are a lot of patterns that are the same here in what I just presented. And if this is very technical, I promise you, we're going to move away from this very technical part in a bit. But this is the basis for what we're working on. And this is what we work really hard off of. We're seeing a lot of common factors. So for instance, look at all the temperature plots there. They're all showing an increase in temperature. They're all showing that it's getting hotter. They're all showing that the continents are getting hotter, more hot than the ocean areas. They're showing that the northern hemisphere, particularly far north, as well as the Antarctica region, is getting the worst of it. We're seeing in terms of precipitation, the blue again is increased precipitation, the brown is decreased. We're seeing some real chances for droughts, for lack of precipitation, and changes that can really hurt us, sometimes in the middle of continents, and which are often where we're getting most of our agricultural output from. So all of that affects how well we can feed our population. So we're seeing a lot of differences, but those differences actually make sense and they're real patterns here. So that is the actual basis for it. We update that basis all the time. And now, again, in trying to help you understand all the various stories that come out about climate science, I'm going to focus on about 7 areas that really are priority areas for us in the climate world to really work on, and that we're looking for improvements. So again, I'm trying to help address this sort of, oh my gosh, there are just so many aspects of climate change. How do you make sense of them? And these are the 7 categories of how I think of it. First of all, there's melting ice and global consequences. So when our glaciers melt, they just add to the sea level rise. When the ocean warms up, the expansion of water adds to the sea level rise. So both of those things are about half the reason for what we're experiencing in terms of sea level rise. What we're seeing in the northern hemisphere in terms of the sea ice, the glacial sea ice, is we're seeing that the ice extent is going down each year. So we're getting less and less ice in our glaciers and more ice in melted ice in the water. When we look at the southern hemisphere, and Antarctica is huge. It's not just huge in terms of its geographic extent, but it's incredibly thick in terms of how much ice we have there. What we have been seeing is a lot of variability up and down, one year after the next. But we're actually seeing a lot less southern hemisphere extent in the last few years. And this is one of the things that we will look at very carefully, because we're really worried that all of this change is not going to be steady and constant, but that we could get some real changes that just take us in a less steady way. It's much harder to respond to these sudden things, and if we understood them better, we'd be able to predict them better. But right now, we're still in the learning phase, particularly in terms of how fast we can expect future change to take place. So in terms of the melting ice and the global consequences, so that's the Arctic sea ice that we're looking at. The sea ice doesn't bother us so much, but the glacial ice does. If you can see it on that map, there's a small orange line, and that's the historic averages of where we see sea ice. Sea ice comes and melts every single year, but even at its lowest point, we typically have about half that area covered with sea ice. And then for the Antarctic, that orange line again is what we typically are used to having, and now you're seeing what we are currently having in terms of the sea ice. So what we're noticing is we're getting some real changes going on, and we want to understand it better so that we can predict it better. So that's one area that you'll hear. You often hear about large chunks of ice falling off from Antarctica. You'll hear about glaciers melting, and what you should understand, especially living here in Miami, is the impact that has on sea level rise and how that can go. It's also one of those things that's hard to reverse. It takes a long time for glacial ice to build up year after year, and yet it seems to be rather easy for it to fall off into the ocean and then melt. Second area that I want to talk about is clouds, circulation, and climate sensitivity. And this is one of the things that I don't know whether people are hearing about it, but this could have drastic impact on the weather that we have. So we're sensing that the tropical area is expanding, the area that's dominated by 2 rainy seasons each year. The tropics are expanding, that the typical weather patterns that we're seeing may well be changing, that the style of weather is changing, that the severity. So how our clouds, how our precipitation, how our weather patterns are going on. The next area that I want to talk about is the regional sea level change and the impacts, the coastal impacts that we're experiencing. So this is a plot going back from 1880 till about now. And I ask you whether or not you see that this is accelerating or whether you see just a steady increase. And for most of us, what we're seeing right now is we're seeing an increase in sea level rise. And that has incredibly devastating potential for impacts, particularly if it really accelerates, if it starts going faster and faster and we get more and more flooding going on. So that's, I think, the third level that we're talking about. And the sort of flooding that we're seeing, I mean, we talk about it often when it comes to Florida, but just to educate you, you might think, oh, well, in the Arctic, they don't need to worry. But actually what happens in the Arctic is all the built up sea ice right at the water's edge ends up protecting the land from the incoming waves that have a very destructive aspect on what's going on. Without that protective sea ice, then what we get is this, all sorts of parts of the land around the Arctic Ocean just falling off into the water. So in that case, the ice was a protector of what we were looking at. Water for the food baskets of the world. I've mentioned this a couple of times now because it's just so important, especially if we don't have this steady change in precipitation, or especially if our clean water gets infiltrated by all sorts of other pollutants. And we've been in a moderate level of drought for much of the western part of the US for a couple of years now, and that's really problematic because so much of our agriculture comes from these areas. We're expecting that to potentially get worse into the future, but we're really trying hard to improve our predictions on this. Another aspect, and this is perhaps one of the most important ones in terms of what we can possibly control and therefore mitigate, is the carbon feedbacks in the climate system. So we emit CO2 every time we turn on our gas burning cars. We emit CO2 from our coal plants. We emit CO2 when we burn natural gas. And that CO2, as we've discussed, just keeps going up year after year after year. But there's also methane. And methane is plotted now on the right here. And we have seen in the last couple of decades, an increase in methane in the atmosphere. And that's partly due to our fracking for natural gas, and it's partly due to methane being released naturally from the tundra and other frozen parts that are warming up and releasing the methane more naturally. It's hard to stop that. So if we have an acceleration of methane, we're going to have an acceleration of CO2 in the atmosphere. So you'll often be hearing about methane and CO2. Near-term climate prediction, boy, but if anyone wants to be wealthy in this room, solve this problem. Get us out of our inability to know whether or not the next season, the next couple of years are going to be wetter, hotter, problematic, more tropical cyclones, less tropical cyclones. The Atlantic hurricane season, this was back in 2022, it was forecasted that we'd have 16 to 20 named storms, 6 to 8 hurricanes, 3 to 5 of them being major hurricanes. But in reality, the predictability is not so great once you're out past 30 days. It's dominated by the ocean and different groups. This is Colorado State University at the top, going all the way down to the Weather Channel at the bottom, each predicting how many named storms that we were going to get in 2022, and the actual number was 14. So we do our best to get this right, but we don't always succeed, and we're still working on it. But in terms of extremes, and this does get into the news quite a bit, and we are working on it as well as we can, we've got a lot of different types of extreme weather. We've got storms, and we've got tropical cyclones, we've got tornadoes, we've got fires, we've got drought, we've got really very heavy precipitation. And each year we look at how many billion-dollar weather or environmental challenges we've had that year, and that just keeps going up, not because of the inflation, we keep the dollar value the same, but it keeps going up. But perhaps more importantly is globally. The World Meteorological Organization releases information in conjunction with NOAA on what each country is dealing with and what the big disasters are for extreme events. And those just keep growing and keep continuing. And our resilience is not, we're here in the US with our very nice air-conditioned systems and our very nice buildings. We are not immune to these damages. It is an international problem. And even if we were immune to this, it wouldn't be the right human decision to ignore what's going on in the rest of the world, especially when we're such major contributors to the CO2 in the atmosphere. So I've given you my vision of the 7 ways that you'll be hearing about climate, but these are not just my ways of hearing about the 7 focus areas for climate. The World Climate Research Program out of Geneva has identified these as being our real priorities that back in 2017, and so we've been working on it quite a bit. The United Nations Environmental Program has been doing it, and this is a sort of area of science where we have to be collaborating with each other. It's no good if the German scientists come to some conclusion and the US scientists come to another conclusion and we don't have a meeting of the minds. So we're constantly working internationally to try to understand what is our consensus statement? Well, how well do we understand this issue? What are we willing to say as a group? Where can we make progress? And through that is the Intergovernmental Panel on Climate Change that produces reports about every 4 to 6 years and says this is our major conclusion on what's going on, but also what we feel is coming down the road, and also what are the impacts. So part of what we're leaning into very heavily, and this has partly been because a lot of community members have been saying, hey, we don't trust you. We don't trust you. And I hear that and I go, okay, tell me more. But part of it is we keep open data sets, and we're leaning further and further into that, and that when we publish papers now, we have to share our programs that show exactly why and how we come to different conclusions so people can reproduce it. And I think all of that is more work, but I think it's important, it's necessary, and I think it's important in terms of bringing people into the conversation. Oops, so so we've got these 7 foci, and I have them listed there on the left, and we focus on a few different things. We look at long-term trends. Are things progressing as we think they should be progressing? Are they progressing faster? What do we have to learn from all of these observations that we take? We try hard to understand the mechanisms, and that involves often going out and taking detailed measurements of some phenomena we want to study, like tropical clouds or how icebergs are formed off of Greenland. And then there are the short-term phenomena, really doing better at understanding some of these extreme events like hurricanes, etc. So I want to lean into the 2 topics that are the way we respond to climate change. And those 2 topics are adaptation, just deal with it, understand that this is what's happening, and maybe dealing with it means not building in certain areas, or building levees that can handle what we're expecting in the future, or developing drought-resistant crops, or educating people so that they know what to expect. So we have flood, heat, wildfire, drought, lightning, hail, tropical cyclones, an awful lot of areas where we want to let people know, here's our current best scientific understanding of what's going to happen, and here it is at a spatial scale that you can handle. For instance, if you just care about your hometown, or if you only care about your particular house, or you care about Miami Dade College at this campus, you can sort of better understand what are your personal risks in terms of all of these different parameters. But we really need to be thinking globally. Even if each of us individually wants to know how safe are we going to be, we can take a look at exactly how many people are being affected right now. So for instance, what you're looking at here is the percentage of the world's population. If you look at, for instance, that 19 number, that's 19% of the world's population right now is dealing with heat. If you go into the next column, we're talking about maybe as we get into a slightly warmer climate, it might be a little bit less, 18% of the world's population, but 5% will be dealing with extreme heat, and extreme heat absolutely has the ability to take lives. And if we get up to 2 degrees C, above pre-industrial, we're still talking about 19% of the population having to deal with heat, but now we're talking about 15% dealing with extreme heat. So extreme heat means you shouldn't be working, means that the elderly are at risk, and it means that children are at risk. In parentheses, there is the population in billions in terms of how many billions of people are affected by heat, drought, etc. So we really need, as we're thinking about adaptation, is not our own adaptation. We need to be thinking in terms of the world's adaptation, and which of these issues are the most difficult is determined by where you are and what your particular risk is. Right now, I'm working with the United Nations Development Program to try to make sure that they have the information country by country that will help each country plan for whatever is their biggest threat. Here's our salvation. Here's our possibility for hope for the future, is really mitigation. Let's quit pumping so much CO2 into the atmosphere if we can. Let's look towards carbon-free energy. Let's at least lean in that direction. And we've got some really good news, some really hopeful news in these areas. Not hopeful enough, but boy, are we kind of leaning in the right direction. We've got wind, solar, and geothermal energies, each making progress. We have some really ambitious under the current funding situation. We're looking very hard at carbon capture and storage, and we're looking at geoengineering, which is a way of like tinkering with what's in the atmosphere to see if we can try to stave off the worst of climate change. Okay, this is my Rorschach test to see who's a geek in the audience, because I love this plot. So I love this. What this is showing is from 1975 through 2021, how efficient our best solar panels have become. And we've got lots and lots of different types of solar panels, and each year they get better and better in terms of how much cell efficiency, how much they capture. This comes out of the National Renewable Energy Laboratory each year. And we don't use all of these types in actual putting them on our houses, but everything is getting more efficient at capturing energy. We're also getting much, much better at storing energy so that it's there when we need it. We can take a look at how much renewable energy is being added year after year after year on a global basis. Oops, didn't mean to switch by that so fast. But we're seeing that over and over again, we're having more renewable energy added to the system. Last year, China was really kind of aggressive. Well, China has been aggressive in renewable energy over the last few years. And that's been going very nicely. So there's a lot of science that goes into mitigation. There's lots of science that goes into adaptation. So I want to pause now and just summarize the science. The science of climate change just continues to advance. My colleagues and I are working hard on it. I hope I've identified some of the areas where we're more confident, some of the areas where we're not as confident. We've got physical, chemical, and biological understandings going on based on first principles and also based on observations and models, incorporating the best of what we know. We have priority areas. You will continue to hear about those priority areas for years to come because they're both important and hard to tackle. And there's coordination going on internationally and in a cross-disciplinary manner. Adaptation science helps us understand specific risks so that people and ecosystems can be as safe as possible. And mitigation is booming with advances in wind, solar, and geothermal energy. I want to just jump ahead, though, to one, because I think I should be wrapping up so we can hear your voices. One area that I'm particularly interested in is, we talk about what does 1 degree of change mean to the world. The changes are happening at mean levels, frequency and severity of extremes, and there are changes in who is affected by all of this. But weather forecasting continues to get better, and the world continues to change. You won't all appreciate this, but I'm going to say it anyways. The head of AccuWeather was at a big meeting of weather scientists in 2002. And he said, someday people are going to get their weather forecasts on their phone. And this room full of weather scientists burst into laughter. That was a preposterous thought 20 years ago. And now, who doesn't have a weather app on their phone? So the world changes, and the world changes in time periods that are incredibly relevant to those of you in this audience. Our hurricane forecast, this is our sort of, our temperature forecast, continue to get better. That's the amount of error on the left-hand side in terms of our 3, 4, 5, and 7-day forecasts. Our forecasts continue to get better. Our hurricane track accuracy continues to get better. All of this is our understanding of the Earth getting better. Our ability to forecast fires is getting better. Looking at sea level rise, roughly half of it is due to the melting land over ice. We have the drivers continuing. We're understanding more and more about the drivers of CO2. We've got expected changes in the environment, and we've got a lot going on in terms of the various forcings and understanding that. So our understanding of the Earth system just continues to improve. I want to jump forward to one last slide to show you what I think is really driving the change of this. Our installed capacity, how much renewable energy, solar energy. We have enough solar energy in the US to power the entire US electrical system if we so chose that. We have enough wind power just throughout the middle of the United States to power the entire United States. We could be leaning into that. We've got one cost of renewable energy continuing to decrease, and that is the driver. And this is the plot that I want to show you. In the middle, the gray area that's sort of going up and down around 0.1, that's how much traditional electricity costs from coal plants, et cetera. And then if you look at, for instance, let's look at solar photovoltaic, the yellow dots in roughly the middle of the plot. 2010, it was about 3 times more expensive. 2020, it's cheaper. So what we're looking at is renewable energy has gotten cheaper and cheaper and cheaper. So there is absolutely reason to believe that we have, and we're seeing that with a lot of the other renewable energy products, they're not only getting competitive with coal in the last 10 years, but they're getting cheaper. So all of that is a good reason to expect hope in the future. I'm going to skip through all of this and just, I wish I could just jump to the end. But what we're seeing is that our use of buildings, our building powers, our planning for the climate, I'm almost here. And the reason for hope is really the International Renewable Energy Agency keeps track of each country and how they're doing on renewable energy. And what we're seeing is that the majority of citizens now take this risk seriously. That's the majority in the US and the majority globally. We have a better understanding of possible actions. Renewable energy is better and cheaper. Electric vehicles are absolutely on the rise. And I want to just point out that at least 3 of these are not due to scientists. These are due to the change makers, the citizens of the world deciding this is the direction we're going in. Energy storage is improving, climate science continues to improve. So there's reason for hope. We may have been laughing 20 years ago about the idea of weather forecasts on our phones. I look forward to understanding what we are going to be laughing about in terms of climate science, in terms of what's possible, and it's all in your hands. Thank you.
So we have microphones in the middle. There's one over there and there's one over here. So anyone with questions, please queue up and we'd love to hear what questions you may have. And also those of you who may be watching streaming, we're able to take your questions as well. So put any questions you may have into the Q&A.
Or anyone want to share their thoughts on the topic? I mean, there are many aspects I didn't address, climate justice being only one of them.
I only have one question, and it was about one of the slides that you have where it showed areas that were becoming extremely dry and other areas that were experiencing high precipitation. You made a comment about the areas that are getting a lot of dry, and it's our agricultural centers. What areas are we forecasting, are you all forecasting, are going to be very intense with rain? Is it mainly falling in the oceans, or is there any particular landmass that's going to be experiencing high volumes of rain?
Yeah, we often, it's often the coastal areas where we're expecting increases in precipitation. If you're following what's going on in California with the sort of atmospheric rivers, oftentimes what the atmosphere does is it picks up the water over the oceans, picks it up as water vapor, and then brings it over onto land and dumps it. So coastal areas are really high at risk. But I want to repeat that our ability to even measure precipitation accurately is so challenged. And as we try to do it globally from satellite, that's even more challenging. It's not just a matter of any one individual storm. I don't know whether you call up your friends and say, oh, we got pummeled with, really, we didn't get any rain. It's not just individual storms, it's that climate, it's that annual amount that differs so very, very much. So it's a hard one to measure, it's a hard one to forecast, but as you repeated, one of our tendencies is seeing more droughts near our food basket areas. Yes. Hi.
Hello, good afternoon. Well, my name is Enrique, and I had a question in regards to your list of mitigation. So a lot of automakers are shifting over from creating combustion engines to electric engines. And there's this question of whether or not the whole method of achieving finding lithium for lithium batteries for the cars is like, it's not ethical. So I was wondering if you feel as though like your professional opinion on whether or not electric cars are the way to go.
First of all, I absolutely believe electric cars are the way to go. And I vote with my pocketbook. I bought an electric car last year. But that's after years and years and years of studying it. So first of all, what I want to say is those are absolutely valid, appropriate ways of thinking of it. You don't just think of, oh, I'm not spitting out CO2. You think of what happened to get me to this vehicle, and what will happen when I'm done with this vehicle, and what happens while I'm driving the vehicle. So it's absolutely the full life cycle is how one has to think of it. I am astounded at the improvements that are going on in battery technology. And if you're following what, for instance, Tesla is doing with all of their advances, and they're some of the leaders in the field right now, they're leaving their patents open so that anyone can use the advances that they make. They're getting more and more efficient, but they're also relying less and less on some of the trace minerals that are so problematic. So I think that that's incredibly hopeful. They're doing it in part for the right reason, or what I might call the right reason. I don't know about you, but it's just more sustainable. It's the appropriate thing to do. But they're also doing it because it makes sense business-wise for them to not have to go for some rare quantity that has a finite existence here. So I think we're without a doubt going in the right direction here. Part that I also want to point out is that local air pollution that is really associated with the cars and trucks that that use combustion engines cause an incredible amount of human harm in terms of damaging to the people who are near it. There are studies where we have bicyclists going on with these little sensors on their bicycle measuring, and just being even within sight of a major truck reduces the air quality. Being within sight, being next to a road as opposed to having a bit of greenery in between themselves and the road can change the air quality that they're taking into their lungs by a factor of 4. So there's a side benefit, which is the human health aspect, but I do think we're cracking the nut on the sort of trace minerals and what goes into the batteries and what we do after it. We're also seeing a lot of the electric vehicle companies having absolutely specific plans for recycling those batteries. And again, it's the dual reason. It's right for the planet, but also they don't want to have to mine it. They want to be able to grab what they already had. But you asked the question, do you have another opinion on this? Do you think we're looking at it the right way?
I mean, I think that it is a really good approach, but I did feel as though like there's a in older generations, people tend to be like, oh, electric cars are a good move, but are lithium batteries, and I know in mostly third world countries, they abuse of the working laws and things like that, and underage children. So I feel like the ethical reasoning may be a little bit lacking, but as with everything, time, things progress and legislation, things like that come into reality. So I think that with time it will get better, but I feel like the way we're doing it now is not the most efficient. Like you mentioned Tesla, but there's hundreds of other companies that are getting into the electric car business. Like just recently Dodge, they're phasing out the combustion engine, the V8, and they're switching over to electric. And it's I don't know. I think some companies could take better approaches.
I agree. And I just want to kind of bounce back another question to you. My naive impression is that our collective eyes on what's going on throughout the entire life cycle is a fairly powerful pressure, possibly not as powerful as the economics of it all, but fairly powerful. Do you feel like our eyes on that issue is one of the most important ways forward?
Well, I think financial support of a cause is definitely a big mover for change. So if we were to put our pockets towards electric cars, like I recently got a car a couple of years ago, I was considering getting an electric car, but I was like, okay, these batteries last 50,000 miles, but if I decided to keep this car for 5 years, then I'd have to, pay for another battery, and it's a whole mess. So I was like, okay, I'm weighing my options. I'd rather get a combustion engine, so I got a gas car. But if people were to really focus their pockets on the change, then I feel like we would really be able to make a bigger impact.
Yeah, one of the most difficult things about following the electric car field is how you got these huge fans and you got these huge detractors, and they're both speaking in such extreme ways that as a scientist, I don't always feel like I can trust what either extreme is saying. And so that's where this whole scientific, hey, show me the data, blah, blah, blah. I want to suggest, because you're nodding your head, I want to suggest to you that you and I both, look into what's the data about the idea that these batteries last 50,000 miles. Because I have a few friends who have 400,000 or 500,000 miles on their electric vehicles. Not a battery problem yet. So let's kind of be aware that people have their perspectives on it, and let's get to the truth, because the more important a problem is, the more important getting to the truth is. Yes.
Right.
We want to make informed decisions, and we can't make it with the extremists trying to talk us into something. So, I'm absolutely quite serious. Let's you and I look into this and share what we find, and yeah, because I don't buy the 50,000 miles bit, but I'm happy to be wrong.
Really. Thank you so much.
Yeah, no, thank you.
Hello. Yeah. First of all, my name is Laureate, and thank you for coming and showing us this amazing presentation. My question is, what would be your advice for this next generation of youth in order to start promoting and supporting this change in the climate science, and also how can we open the eyes of those who are who are in power, or how can we try to influence people who are not really focusing on this problem right now? Because I'm pretty sure everyone has their own issues in their lives, but because if just one country or a few countries focus on this problem, it will not probably be not enough in order to solve this issue. So yeah, that's my question.
I agree. I think I agree, but let me make sure that I understand what you're asking is, how do we collectively address this problem? Because it probably won't be solved by individuals buying electric cars or something. Is that how do we work across a lot of different belief systems on this issue? Is that your question?
Yes, but not only in only cars, but I mean, maybe there are countries or communities that don't really focus on this issue much, or
Yeah.
maybe we don't think about it enough.
Right.
We're going out in our lives, and it's it just passed by.
Exactly. I think, and I was only trying to use electric cars as an example.
Yeah.
Yeah. I think that we need to be talking to each other, but I also think that the real experts on, to answer your question, are the change makers in this room. Because as a scientist, I'm constantly talking with other scientists, trying to, hey, can we improve our understanding of that by another 1%? I am not in general trying to talk to people and try to get them to live life differently. I like to be that person who will give an honest, independent, here's our best understanding kind of response. And as a scientist, I feel like it's really valuable for me to stay in that, here's my best understanding, not I want to talk you into buying an electric vehicle and I want to talk you into recycling more. That's not my role, because if I took on both roles of trying to understand, I might end up skewing my science a little, I'm trying so hard to find an answer that will make people alarmed. No, I need to just find the right answer. So anyone from the changing group that wants to respond to that question, or you ask the question, do you have thoughts on how best to convince people who are not fully on board yet?
I feel like this issue cannot be solved only. It cannot be the only one being addressed, because I feel like other issues are also impacting this climate science as well. For example, poverty or hunger. Because when you have these issues, people have less time to think about the one that's coming in long term. So I think that's also something that we have to address as well.
I fully agree. I fully agree. Yep. I also, one point I didn't make, if you remember that CO2 plot that was going up, 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 up every single year, I want you to think for just a second. We all lived through the pandemic, the global pandemic, where there was a whole lot less flying, a whole lot less driving, a whole lot less of anything. You could hardly see the impact of the pandemic in that plot. We still kept on spitting out unprecedented levels of CO2, which I think goes in part to part of your premise there, which is it's not going to be trivial to really make impact here, especially when people are dealing with so many other things. So it's not going to be, oh, let's all turn our air conditioning down a little bit. That won't get us there. The numbers just don't work out. So, but I think the change makers are better to talk about talking across belief systems. I hope to be an honest broker.
Thank you.
Thank you.
Hello, my name is Camila. I had a question about when you mentioned hydropower and the ability to wind to be able to like sustain all of the US. I wanted to know your opinion on if biofuel will ever be able to reach that sort of capacity and if it's going to be endangering our biodiversity.
Yeah, I think biofuel has a lot of challenges, in part because biofuel still is putting CO2 into the atmosphere, and so it's only a temporary solution. It removes some of the air quality problems, but not all. So I don't feel that biofuel is the way that is going to take us out of climate change. It can be a temporary a way of addressing it. I think wind, solar, geothermal, hydrothermal are all going to be our more promising answers.
Thank you.
Yeah, my colleagues and I, we just keep looking at that CO2 number, and anything that doesn't bring it down doesn't feel like a solution.
So Dr. Weatherhead, before we take another live question, we have one in the chat that we haven't taken any of their questions yet, but we're being asked what negative impact is foreseen on mining minerals for battery production?
Yep, and I have to defer and say I'm not that much of an expert on mining and the impacts. I'm following it, kind of loosely following the topic, but I would hate to speak to this, other than saying that what I'm seeing over and over again is the minerals that we thought were absolutely essential to our battery storage appear not to be, with all the breakthroughs that have gone on in the last 10 years. But I'm an atmospheric physicist, so I don't want to step outside of what I understand. Forgive me.
Thank you. Well, we're beyond grateful for you being here and speaking with us and having that conversation with our students. So thank you. I did Peace Corps in Bolivia, 99 to 201, in a town that did not have electricity.
And what were your last words?
So I did Peace Corps in Bolivia, 99 to 201, in a town that did not have electricity. There's a lot of people in the world that are still living in underdeveloped, that don't have the privileges, the electricity running in their houses, the cars, and we don't want to deprive people of the lifestyle that we have. It is not fair. But as more and more people move into having a higher quality of life, there is going to be more carbon. It is unethical of us to say, you can't enjoy what I enjoy. What changes can we do? How can we?
Absolutely, absolutely. Well, we're already seeing some of the changes that can take place. So, for instance, the renewable energy becoming just as cheap as coal power plants, and yet renewable energy, a wind turbine, solar energy, can be established within a week, whereas it takes at least a year to build a coal power plant. So the idea that how we lean into this is leaning into it with renewable energy, as we have our wonderfully expanding middle class with their desires. That can absolutely be the way forward. As we look at all the positives of that, giving a community its own electrical ability and control over it, not something that is managed by some bureaucrats, perhaps hundreds of miles away. I think that is the way forward. The storage issue, the battery storage issue, particularly if we can do it in an appropriate way, is just embedded right into that as being one of our great solutions. But we are all thrilled with the decrease in severe poverty and the increase in the middle class, and we absolutely do not want to be requesting of them anything that we wouldn't request of ourselves.
Thank you.
Good afternoon, Dr. Weatherhead. Thank you so much for being with us today. I know that you're a climatologist and not a nutritionist, but I do have a question because there's a lot of noise going on about the proper diet for when to eat and like how that impacts our climate. And so I'm just curious if you know any information about how maybe supporting a plant-based diet correlates to the climate and how it affects our climate.
Oh, there's so many ways in which a plant-based diet is affecting our planet, or the lack of a plant-based diet is affecting our planet. And a lot of it has to do with the types of animals we eat and the way that we raise those animals. So the belching of cows and the, methane that's released from a lot of the effluent from the chickens, et cetera, in this really intensive farming methodology that's been embraced by North America and in some parts of Europe and some parts of Asia, is so damaging. How much of our land has to be devoted to that type of agriculture in order to support one person is a real push, a real driving factor. So even if we got rid of all of our coal burning plants and all of our gas guzzling vehicles, et cetera, all of this extra methane is going to turn into CO2 eventually. So we need to care about that, and we need to care about what sort of planet we want to live in. So it's completely embedded in there. It's not the biggest driver, but it's absolutely a factor.
Thank you so much.
Is that your perspective?
Well, actually, I've been pescatarian since like around the 7th grade, and I've tried a vegan diet and I've tried a vegetarian diet, and I do realize the health benefits of that, but I know that it's not sustainable for everybody to have that diet, and so yeah, I've seen documentaries and about how eating fish and like that commercial agriculture can be harmful to the environment. So I was really just interested in learning about its impact, and whether it's maybe a responsible choice for us to be leaning towards a plant-based diet, or maybe we just need to be focusing on where we're getting our meat from and maybe focusing on smaller, more sustainable sources for that.
Yeah, it's not just where we get our meat from. It's just the idea that we devote so much land and so much activity there, and that those animals all produce so much methane, and their waste matter produces so much. But I love the way you describe that in terms of leaning into it, not as I have not eaten a single hamburger since 7th grade, or maybe that's even true.
No.
But it's kind of like we need to find solutions that work. And we need to find solutions that work individually. We need to find solutions that work for the US. And most importantly, we need to find solutions that work globally. And it's all about breaking with what we thought was the only way forward. And so creative thinking and really balancing the different choices, I think what you're sort of exemplifying.
Thank you so much.
Thank you.
Hello, my name is Ben Gonzalez, and thank you for being here. And I wanted to go back to when you mentioned the different sources of energy that have a less impact in the environment. I just noticed that as for now, the most two famous to hear like this is solar energy and wind energy. And I just start to notice that almost every source of energy has its limitations at some point. It can be because of the cost of the production. For example, to construct a wind turbine is really expensive, and not every place can use it. Solar energy has its limitation in terms of if the area that you live receives enough sun to make the panel work. And what I want to go with this, I see that every year there's a new way to produce energy that has a less impact on the environment, like biofuel was mentioned. And like you mentioned, it's not really a way to go because it still produces CO2, not as coal, let's say. But for example, in Japan, they're doing this where they're producing energy using footsteps. So how this works is in the subways, in the public transportation, because it's really populated, they install some pads where every time a person walks through the pad, it creates a small vibration that stores energy. And this energy is just enough to light the signs. When I first heard it, sounds impossible, but it's just amazing how every year they're developing a new way of developing this kind of energy, like footsteps, who would not think of that. But my question really is there going to be like a defined source of energy that's going to be sustainable to have a less impact in the environment? So the production of CO2 is in the future, it's going to be one defined energy, or it has to be like a working team of the other resources in order to make one source of energy self abundant.
Yep, yep, and thanks. And I've been around this long enough that I keep on hearing new ideas of energy production, and it's a really wonderful, fertile topic for, like, can our footprints give us that vibration that gives us what we need? And there are two things that I've learned from this, and the first is that economics drives what succeeds and what doesn't succeed. It just does. And so lots of people in their home garage are like, hey, I think I can, oh, look at this, I can, charge my battery and all that stuff. It all comes down to economics. I've heard some kind of crazy ideas. I've heard of, let's get all the homeless people together and get them on stationary bicycles and get them producing some electricity for us. And it just comes down to, okay, we keep evaluating that on how much does it cost and how much do you get for it, and so many of these very novel ideas just don't even begin to pass that test. But we have to look further down the road, and not with the homeless people, but we have to look further down the road and say, okay, our first effort at this hasn't been really successful, but could it be successful as we go down the road? And right now, the Department of Energy is putting a lot of effort into this, and they always have, and just trying to find what are the solutions that work, what will get it. And part of the interesting part, and this alludes to one of the prior questions, is the solution that works for us in the US may not work for people up in the Arctic, or it may not work for an island nation, or, we've got these various different needs of what they can do. So for instance, in the US, we basically have three electrical grids: the Eastern grid, the Western grid, and kind of the Texas sort of grid. And so as long as there's wind and sun shining someplace in the Eastern grid, they're kind of good. They just move it around to wherever they need it. Similar for the Western grid, Texas grid. And so we have that incredible benefit. But if you're a little island and it's not sunny for a few days in a row, solar panels aren't going to be your solution. So getting that right mix, and wind, solar, geothermal are not the only things we should consider. We need to get the right mix for the right location, and we need to keep investing in new ideas. But the ones that succeed are going to succeed because they either fit a niche or they actually are economically viable and just truly make sense. Does that jive with how you think of it?
I don't know. It's interesting because I just got into this topic of the new source of energy now that I was involved in research with biofuel, and I just found it interesting when I hear that, for example, what I mentioned before with Japan, that food steps are being transformed into energy. Maybe not enough energy to power a city, let's say, but it all comes down to the money first,
Yeah.
of how it costs to produce this equipment, and also what consequences might this energy bring. So
Yep.
that's why I ask if in the future it's going to be like let's say so if solar energy is going to be the way to go, and that's the one that's going to predominate, or if solar energy needs the help of the other source of energy to be there and replace coal, let's say.
Yep, I think in general it's a mix that's going to work, and I just want to reiterate that there's a lot of investment going on into trying to expand our suite of possibilities for producing energy. It's both private sector entrepreneurs who are hoping that they're going to, make their millions, billions, I don't know, to the Department of Energy investing in small ideas and nurturing them and allowing them to grow. So I think we're all going to keep our eyes open. I mean, there are also some unusual ideas that possibly are not that well known in this group. For instance, the currents within the ocean and the waves on top of the ocean. Each of those, as well as a variety of other things, has these ways of producing energy that are pretty useful. And we always have waves at some level. We always have ocean currents. So that's one of their pluses. As an earth scientist, part of our role is to look, what's the right place to put those in, where we have a steady source of energy and can expect it, where the impact's going to be minimum, and what can we predict whether or not that source of energy is going to work, not just for the decades to come, but for the few days into the future. Because if it's not going to work for the few days into the future, then we need a backup effort. And in general, we can turn on natural gas in a second in terms of producing electricity. If we want to turn on a coal burning plant, that takes 24 hours to fire it up. If we want to turn on nuclear, that takes a week to get it going. So because all of us want steady electricity, when we look at these alternative points of energy, if there's going to be any intermittency, we're always looking for a complementary source of energy that will help us make it work in the system. So we keep looking for new ways of creating energy. And my best guess is that the next set will come from ocean currents and wave energy. We can do it now, we just can't do it cost effectively yet.
Thank you.
More questions?
All right.
Hello, doctor. So I just had a question.
Could you tell me your name?
Oh, I'm Gabriel Sayak. Nice
Thank
to meet
you.
you. When we're talking about the subject of sustainable energies, I wanted to know your opinion on nuclear energy and if it's a sustainable way to live despite the lack of ways to store nuclear.
Yeah.
yeah.
I have my opinions, but they're my personal opinions. As a scientist, I have the exact same concern that you just expressed. What do we do to store this? Can we do it safely? Are we likely to be able to do it safely forever and ever? I will more speak for my colleagues, for the broader, environmental science community, in that I hear different thoughts from my colleagues. Either they're like, hey, it's a necessary evil because we got to stop that CO2 from growing, or they think, nope, too dangerous, too dangerous, too dangerous. But those are opinions that I'm sharing with you. It's but my colleagues, I feel, don't have a consensus. I have just one opinion. I don't think it's that valuable, but I think these are the hard choices we have to make. Are we willing to risk it? What makes us feel like it's safe? Do we want to raise our families right next door to one? That's almost like the hard test of, do we trust this? So yeah, we've got a lot, but this CO2 business, part of the challenge is not only does the CO2 last for so long once it's up in the atmosphere, once we warm up the oceans, it is a really long time for those oceans to cool off. So we are not just kind of cursing the next 500 years, we're really sort of causing problems for even longer down the road. So I respect people who are in favor of nuclear. I also respect people who are saying, hey, that's too dangerous. I don't have this is the way to go.
Thank you very much.
Yeah.
Thank you, Dr. Weatherhead.
Thank you. Thank you all.
And thank you all for joining us today here in the auditorium and streaming live. And again, please check out our schedule for the rest of the week. We have some more events tomorrow as well as through next week. Thank you.